In this lesson, we're going to be solving systems of equations by using elimination. To solve a system by using elimination, your goal is to eliminate one of the variables by getting the same coefficient in front of the variable that you want to eliminate. One of them should have a positive sign, the other should have a negative sign. I'm going to add the two equations and solve for the remaining variable, and then repeat the process for that we used for substitution. All right, first example. We already have for the x's, we've got the same number in front of the x's, 4's. Now one of them is positive, one is already negative, so we don't have to multiply either equation by anything. We could just add them up and the x's will be eliminated. When we add up the y's, we get just 1y. And when we add up the constants, we get 6, so y equals 6. And then we plug that value of y into either equation. I plug it into the first equation, and then multiply -4 times 6, get -24, add 24 to both sides. 4x equals 16, divide both sides by 4, x equals 4. And so our solution is the coordinate 4, 6. That is the point where the two lines intersect. Next example, it would probably be, you could eliminate the x's or the y's. I'm going to go ahead and eliminate the y's. It would be easier to eliminate the y's because I would only have to multiply the top equation by 2 to get a -18 in front of the y. So when I multiply the top equation by 2, I get 8x minus 18y equals -58. Bring down that second equation, add them up, and the y's are eliminated, leaving me with 13x equals -65. Divide both sides by 13, x equals -5. Take that value of x, plug it into either equation. I plugged it into the first equation. 4 times -5 is -20. Add 20 to both sides, and then divide both sides by -9. We get y equals +1, so our solution is the coordinate -5, 1. Next example, it would probably be easiest to eliminate the y's, just because all we have to do is multiply the second equation by 10 to get the same number in front of the y's, one positive, one negative. So when we do that, we get -10x plus 20y equals -19. That's just the first equation. Add the two equations up, and we get 0 equals -9. 0 does not equal -9, so that tells us there's no solution to this system. And for the last example, we can, since we're using the substitution method, we have to multiply both equations. First thing we want to do is line up the x's, the y's, and the constants. But typically, if we had our choice, we would probably use substitution because it would be a lot easier to use substitution to solve this system. But using elimination, we want to put the both equations in standard form, lining up the x's, the y's, and the constants. And then we're going to multiply the second equation by 189. And we do that, and then add up the two equations. We get 0 equals 0. That is a true sentence. So that tells us that there are infinite solutions to this system.